Okay, so we'll have a look at this question here. So question 13. In the given diagram, so the line DE and BC, so the line DE and BC, so they are parallel, and we know they're parallel because we can see this like arrow symbol here. So that means that they will go on indefinitely and never meet. And it asks you to explain why the triangles ADE and ABC. So we have ADE and ABC. So why are they similar triangles? But if we have similar triangles, let me just write this roughly the way that it is. So imagine we have these two similar triangles. So it's roughly like this. Okay, let me copy this. Okay, let's play with this now. So if I just select this one as well, and I just want to make it a bit bigger. Okay, I'm just going to get rid of this and just try and draw this one out. So imagine we have a similar triangle. So it's just basically a bigger version of that one, okay? So we have these two triangles, okay? So the first triangle is the smaller triangle and it's ADE. So imagine, so it's ADE. So the triangle has 3 points, so that's point 1, point 2, and point 3. And then we have this bigger triangle, which is made up of the 3 points A, B, C. Okay, so imagine we've just taken these out. So they're kind of overlapping at the moment, but we're separating them out. If they are similar triangles, it means that the angles are the same. So this angle will correspond with this angle. And this angle here will correspond with this angle. And then this angle here will correspond with this angle. Right. Even more than a correspondence, they'll be the same angles. And then there will be a relationship then between the sides as well. So up here, and then we have, so these angles, I'm just coloring them in. It means that they are the same. Now, what also will hold true with angles as well. So imagine we call this side. So let's say this is A, B, C. We'll call this D, E, and F. There'll be a correspondence between the sides. So it means that, and it matters which way you do this as well. So let's say if we divide, let's say if we divide small, so corresponding, so another thing to realize as well is that this side here corresponds with this side here corresponds with this side, and this side here corresponds with this side. What do I mean corresponds? I mean that there's a relationship. They're similar. They're not the same, but they're similar. Now, what holds true then is this side A is, so let's say if I take side A and I divide it by its corresponding side on the bigger triangle, side D, the answer to that, whatever that is, will be equal to, for example, B, this side here, divided by its corresponding side on the bigger triangle, which is E, and it'll be equal to this side here, which is equal to C, divided by its corresponding side on the bigger triangle, which is F. So what it means is that you'll get the same, it'll be the same ratio or the same relationship that will hold true. Now it matters. Now you can't say, like for example, the side A divided by D is not equal to D divided by A. You're going to get a bigger, like these are not equal to each other. Now if you can do it the other way. So the way we've done it here, so we're dividing the side on the small triangle by its corresponding side on the big triangle. Now you can do the opposite, but you have to do them all as well. So you can say that, so for example, the side D divided by its corresponding on the smaller triangle will be equal to side E divided by its corresponding side on the smaller triangle will be equal to F divided by its corresponding side on the smaller triangle as well. So it matters. So you either go, like for example, this will be small to big triangle, and this will be, for example, big to small. Too small. But you can't say, for example, a small to big side divided by each other is equal to a big to small side divided by each other. So it does matter which way you do, like as in which, if you go small to big, you have to do them all small to big. If you go big to small, you have to do them all big to small. Okay, so that's that. So the reason why they're similar triangles is because, explain why the triangles ADE, why they're similar. They're similar because they have the same angles. So for example, this angle is common to both. This angle and this angle will be equal. This angle and this angle will be equal. Sorry, let me just do that again. So what we can say is, so we just stick with the colors. So this angle here is common to both the small and the big triangle. We can say this side will correspond with this side. Okay, and I'm just going to color that in because there's an X there. And then also, should I say angles? This angle will be equal to this angle here. So that's why they are equal triangles, because they have the same angles. They have corresponding angles and corresponding sides. Okay, so that's that part. Find the length of the line segment marked X. So the line segment marked X. So we're trying to find the length of find the length of the line segments marked X and A. So this X here, and we're trying to find A. So X is basically made up of the points D, what it looks like, D, 2, B. Okay, so it's made up of those 2 points. We want to find out what size that is. So what could we do? So what we can do is we can think about these as two corresponding angles. And what I'll do is I'll just get rid of these letters here, and we'll just use these two triangles. So we can write in the sides. So for example, the side from A to B on the bigger triangle is going to be 6 plus, so it's 6 plus, let's say 6 plus X. So that's the side on 6 plus X. The side, so this side here on the bigger triangle is 9 plus 3, which is 12. So this side is going to be 12, and then this side is A. And then if we look at the small triangle, so this side here is going to be 6, this side here is going to be 9, and then the side along the bottom here is going to be 7. Okay, so now what we want to do is we want to try and work out some of these sides. So if we have a look at, so if we try and work out, so what have we got? Okay, and this is 9. So this is 9. So what we can use this relationship here to try and work out, for example, we'll work out what A is first of all. So what we can say is that, let's say 9 divided by 12, so 9 over 12. So this side divided by its corresponding side will be equal to 7 divided by A. Okay, so these corresponding sides. So we can cross multiply. So 9 by A is 9A, is equal to 7 by 12. So 7 multiplied by 12, which is equal to 84. That's equal to 84. And then we want to find out what A is, so we can divide both sides by 9, like so. So these will cancel out, and A will be equal to 84 divided by 9, which is equal to 9.3. So A is 9.3, so that's equal to 9.3. Now what we want to do is work this one out here. Okay, so we can use exactly the same principle. So we can, and we'll just do it over here. So we can say this side divided by its corresponding side on the bigger triangle divided by 6.x is equal to, for example, 9 divided by its corresponding side, 9 divided by 12, like so. So what we can do is we can cross multiply. So this will be 9 multiplied by 6 plus x is equal to 6 times 12. 6 multiplied by 12, which is equal to 72. 72, and then we want to get rid of the brackets, so 9 by 6, so 9 sixes, so 9 multiplied by 6 is equal to 54. 54 plus 9x is equal to 72. Okay, now what we want to do is we want to get x on its own, so we have to get rid of all the numbers around x. So we start off with this first. So this is plus 54, so we minus 54, and we minus 54 from this side. So that will get rid of that, and we'll be left with 9x is equal to 72 minus 54. So 72 minus 54, which is equal to 18. Okay, and then we can divide both sides by 9 to get x on its own. And that's going to be x will be equal to 9 divided by 9, and 9 is 18. So x is equal to 2. So we can say that x here is equal to 2. So an answer then to this question, x is equal to 2 and A is equal to 9.5. And that's that.